For many years, across entire generations, astronomers worldwide have unblinkingly watched one of the most dazzling and mysterious jewels of the night sky. Her name is Betelgeuse, a majestic red supergiant, a titan that had reached the very edge of its life, poised just one step away from a grandiose collapse. All experts agreed that it would inevitably happen, but no one, absolutely no one, could predict exactly when this epical moment would arrive. And now, in our era, the James Webb Space Telescope has managed to capture what we never dared hope to see with our own eyes. It recorded the very instant Betelgeuse began its final furious act, its explosion. We have become witnesses to the death of a star. We see the cosmic shockwave born from its agony, and a window has opened before us into the untamed primordial power of the universe itself. What is happening is not just another observation of deep space. This is an event of truly planetary scale, one that a generation is fortunate to witness only once. Before us unfolds the explosion of the closest supernova to Earth ever recorded by humanity in its entire history. And what the Webb telescope has revealed has irrevocably changed our entire understanding of stellar evolution. Betelgeuse, holding its place of honor on the shoulder of the mythical hunter in the constellation of Orion, has always been an extraordinary star. This colossal cosmic object belongs to the class of red supergiants, stars that have reached the final, most grandiose stage of their existence. Its diameter is more than 700 times that of the Sun, and its mass exceeds that of our star by about 20 times. For decades, scientists have observed it with unflagging interest, aware of its extreme instability. The star was in constant flux. It would swell to incredible sizes, then dim, then eject colossal streams of matter into space. In 2019, it suddenly and dramatically darkened, sparking a wave of speculation worldwide. Everyone wondered, is this the end? Is it about to go supernova? Now, thanks to the incredible precision and resolving power of the telescope, this mystery has only deepened and become more multifaceted. For the first time in the history of human cosmic observation, we are witnessing the genuine real-time signs of a stellar collapse. We see a massive, uncontrolled release of energy preceding the explosion. We are observing how giant convection currents on the star's surface are changing direction, and how its magnetic fields, twisting into unimaginably complex and chaotic structures, are losing all stability. Betelgeuse is not dying quietly. It is undergoing a violent, furious transformation right before our eyes. The Webb Space Observatory has been monitoring Betelgeuse for several months, using its unique infrared vision to penetrate the veils of dust and peer into the deep layers of the star that remained completely invisible to any telescope built before. And now that the data has finally been received and analyzed, the results are staggering. We can distinguish convection bubbles the size of Jupiter bursting on its surface, like bubbles in a boiling cauldron of cosmic proportions. We are tracking giant plumes of incandescent gas hurtling into open space at unimaginable speeds. And in the spectral analysis of its light, scientists have detected the unmistakable signature of a shockwave that has already begun its journey through the outer layers of the star's atmosphere. For the first time in history, astronomers have the opportunity to observe the very physics of a star's destruction in the finest detail. This is not a computer simulation. This is the true anatomy of a supernova, unfolding in real time just 642 light-years from our planet. This event is fundamentally different from all other supernova explosions that astronomers have recorded, as those occur in distant alien galaxies. Betelgeuse, in cosmic terms, is very close, practically on our doorstep. Its final explosion will be so dazzlingly bright that it will be easily visible in the daytime sky, shining brighter than a full moon. But more importantly, its proximity provides scientists with a truly unique opportunity to study the death of a massive star up close. It is a chance to understand exactly how its core collapses, how heavy elements like carbon and oxygen are forged in this thermonuclear furnace, and how the shock wave from the explosion transforms the surrounding interstellar space. What the Webb telescope has captured is not just the agony and death of a giant star. It is the majestic process of creation itself, giving rise to all the necessary ingredients for the birth of life. We are seeing the birth of the very same elements from which our planet Earth, and ultimately, we ourselves, were formed. In fact, we are observing our own cosmic lineage in reverse. The explosion of Betelgeuse is not just a spectacular sight. It is a fundamental key to understanding the hidden mechanisms of galaxy formation, the creation of planetary systems, and the endless cycle of life and death in the universe. With Webb's incredible instruments, scientists can now model the final moments of stellar evolution with unprecedented accuracy. They can understand what happens inside a star in its final moments and perhaps even learn to predict future supernovae long before they erupt. This is more than science. It is a true revelation, a moment when humanity dared to look into the abyss of time and saw light flash back in response. The explosion of Betelgeuse is not an isolated event. It sends powerful shock waves for many light years around, disturbing and compressing the interstellar medium. The Webb telescope has already managed to detect the early streams of high-energy particles spreading out from the star in all directions, heating the surrounding clouds of cold gas and altering the shape of the star field. But there is something else that inspires even greater awe: the gravitational shift. Even from the colossal distance of 642 light-years, the collapse of Betelgeuse's core should have generated gravitational waves, ripples in the very fabric of space-time, which we have only recently learned to detect. If this hypothesis is confirmed, it will be the first ever observation of a visible supernova directly linked to the registration of gravitational data. And this will completely rewrite our understanding of the fundamental interaction of light, matter, and space-time itself. When Betelgeuse finally collapses, we will face one of the greatest cosmic questions. What will be left in its wake? A super-dense neutron star, a mysterious black hole, or something even more strange and exotic? The data obtained from the Webb telescope already hints that the collapse may be uneven. The disruption of the magnetic field, the formation of plasma voids, and a possible asymmetric fallback, where part of the stellar matter is not ejected into space, but falls back onto the remnant, all point to a highly complex process. Some astrophysicists even dare to suggest that we may be witnessing the birth of a transient object, something between a neutron star and a black hole, whose existence has until now only been theorized. If the telescope has indeed captured this, we have obtained the first direct evidence of an entirely new class of cosmic objects. Many people are now asking, are we in danger? The short answer is no. Betelgeuse is not close enough for its death throes to harm Earth in any way, but the long answer is far more complex. Its explosion will release a colossal wave of high-energy particles, streams of gamma radiation, and powerful electromagnetic bursts. These could disrupt the stability of cosmic clouds in our sector of the galaxy, affect other star systems, and even change how light from more distant regions reaches us. Currently, scientists are carefully monitoring the speed and direction of this radiation wave, because even if we are not personally threatened, this explosion could alter the optical structure of our galactic neighborhood, forever changing the way we observe the universe. Betelgeuse is a huge, ancient, incredibly powerful, yet dying star. It serves as a stark reminder that even stars, those seemingly eternal lights in our sky, have their limits. What Webb has recorded is not just the death of a star. It is a cosmic mirror reflecting a universal law. Everything that lives eventually comes to an end. But in this grand finale, the seeds of a new beginning are sown. New elements are born in the fire of the explosion. New stars will rise from the ashes of Betelgeuse. New worlds may form in the chaos it leaves behind. This is not destruction in its purest form. It is cosmic renewal, and we are incredibly fortunate to be witnesses to this act of creation. Among the vast array of data collected by the Webb telescope, scientists have discovered something completely unexpected: complex variations in the elemental composition of the ejected material. It turns out that the explosion of Betelgeuse is releasing not only the standard set of carbon, oxygen, and iron, but also extremely rare elements like technetium and yttrium, which can only form in the most extreme stellar conditions. Why is this so important? Because a detailed analysis of the ratios of these elements allows us to trace the entire life cycle of matter in our galaxy, from the incandescent core of dying stars, through the dust from which planets are later formed, all the way to the atoms within each of us. Webb is not just recording an explosion, it is deciphering the fundamental chemical script of how life itself becomes possible. And Betelgeuse, in its final majestic moment, is telling us a story that began long before the Earth existed. Betelgeuse will never return to its place. Its position in the constellation of Orion will soon become an expanding cloud of superheated gas and glowing debris, a nebula. But its death is not an end, but a priceless gift. A gift of knowledge, a gift of elements, a gift of a new perspective. It reminds us that our sun, too, will one day be extinguished, that even the brightest and most steadfast lights in the sky have their final act. And yet, from this end, a blueprint for everything new is born. Because without supernova explosions, there would be no planets, no oceans, no life. And now, thanks to the keen eye of the James Webb Space Telescope, we can finally see this complete cycle firsthand, from fiery collapse to the raw materials for new creation. In the cold and silent stillness of space, 642 light-years from Earth, one star has ended its long life. It did so, not with a whisper, but with a dazzling final roar that traveled through the darkness for centuries until it finally reached us. Thanks to the Webb telescope, we did not just see it. We were able to understand it. We saw the omens, the collapse itself, and the subsequent detonation, not as an ancient myth, not as a poetic metaphor, but as an undeniable scientific fact. Betelgeuse did not die in vain. In its final moment, it gave us answers to questions older than humanity itself. Where do the elements come from? How do stars live and die? And what will one day happen to our own sun? In that fading red light, Webb captured something more than just a supernova. It captured our origin story and allowed us to glimpse into our distant future. So, now we ask ourselves, what else is the universe ready to show us? And are we ready to see it? Let us know in the comments what you think about this. Has this event become the greatest stellar performance of our time? And what cosmic secret do you think the James Webb Space Telescope will reveal to us next? Be sure to subscribe and turn on notifications, because this is far from the end. This is just the beginning of what comes after the stars.